It's time for our last talk of the night. Please give a warm welcome to Russell Shean. Okay, yes.
Okay, great. Is the mic working? Sounds like it is. My name's Russ. I work for the Washington State Department of Health. Today I'm going to talk about how we're using batch scripts to download all the R software and Git and things you need to run code and then actually run the code. Sort of building off the previous talk, this would be option 403, which, if you know, is the access denied code. So this is sort of what you use when IT denies access to other things in the cloud or with Docker, and you have to sort of home build an alternative. So starting with this, just some definitions. What is a batch script? The important part of this slide is the write. It's command prompt. Assume most people are familiar with it. In command prompt, you can send a bunch of commands to the Windows shell. It's the Windows terminal. You can also write scripts that are collections of all those commands. They have a .bat extension. To run them, you can double click on them. You can also put them directly on the task scheduler. You can run a batch script from the terminal. So that's just sort of definition if people weren't familiar with the term batch script. So here's sort of the central thesis of why you would want to do this. I don't know if this is, I've had previous jobs where I wrote a cool script in R. It did everything that my boss wanted. It dramatically reduced our work times. We didn't have this Excel-based system anymore. But then when I got to share it, there was this I don't have R installed, or if they did have R installed, they never opened it and they didn't know where you click in RStudio, and there's just a lot of knowledge to how to even get started with R that we take for granted. So this is an alternative way of making R scripts reproducible, alternative to actually training people. It's to just sort of do all that for them, where it downloads and installs R, gets the environment set up, pulls in the code from GitHub, and then runs Go. Okay, great. So that's sort of the general why you might want to care. And then now going to transition to sort of our specific use case at the Department of Health. So just sort of the general outline of what we are. I work on the visualization section team. We are sort of this in-house consultant team for the rest of the Department of Health, where we build primarily dashboards. We do a lot of other things. So if you happen to work for the Department of Health, feel free to reach out to us about some of the other cool stuff we're working on. The bottom thing is the shiny we built. But anyways, focusing in for this, we have one of the main things we do is build Power BI dashboards. That top one is our COVID one. And then within the data visualization section, we have separated roles out further. So the dashboards are built in Power BI, but Power BI is a nightmare for data processing. So we do that primarily in R. So we have an R team, we have a Power BI team. This is sort of just our development process. The data processing pipelines are in R. The dashboards in Power BI. It's deployed through the Power BI service. So then we have this development standpoint or phase, and then we have this post-development kind of maintenance stage. And our process is not ideal because after our team writes the actual code that we use for the data processing, we give that code back to the other team so they can run it themselves. So we have to write code that works both on our machine and on their machine. And it's sort of this blank X computer that we don't know what's installed on and what they already have. And somehow we need to write our code and set up the entire environment in this reproducible way that they can also run our code. So the previous process, this is the before, they have the gym before and after pictures. This is the before picture. We wrote the code, we handed it off to them, and then we would train them on, okay, you have to go to this link to download this version of R, and then our code is on GitHub, and you have to go into RStudio and do the pull command and then copy and paste the link, and then, oh, by the way, you have to install Git. And it was just this very time-intensive process. The initial training took an hour, more or less, for each project, and then we also had constant troubleshooting where people would forget which arrow they're supposed to click on in RStudio to actually run, or they forget you can do Control Enter, and just all these things that we take it for granted that if you're not running R, it's a lot to remember. And then there was also problems of them not clearing the environment, where they have data sets from a previous run and that cause problems and mismatched packages. And I'm sure people are familiar with the potential there. So wouldn't it be great if it was all automatic? Yes, that's why we wrote batch scripts. Batch scripts are a Windows shell language that you send sort of commands to the Windows operating system. I put Windows in quotes intentionally because this concept sort of came to me from Linux, where this approach to downloading, installing software and configuring the environment is much more common. You sort of as a default install software in Linux from the command line, whereas many people using Windows, especially Windows desktop sort of general user, they're used to downloading a file and clicking install and all that. So anyways, this is a Windows way of doing that sort of process. So we wrote batch scripts that check for R, install it if it's missing, check for our tools. We also do our studio. We wouldn't need that to just run the code, but we also like them to be able to look at it if they want. Downloads, installs pan.get. It sort of picks a place to put all the code, creates the necessary file structure if it's missing, and then clones the code, pulls in all that's like the first run, and then you can rerun the script and it'll redo the checks, but it won't reinstall because it'll find all those things. But it will also like pull in any changes from that were pushed to GitHub like in between when they first ran it and when they're actually running the code. And then of course, as the last thing, it actually runs the R Conf. So that I could probably like stop the presentation there and then just share my code. But going into a little bit of detail, just like what specifically I'm doing and sort of highlighting little bits of the batch script and the Windows shell language commands that we use. So the first step is checking for software. There are multiple ways to do it. This is sort of the batch file commands we're using. We're checking to see if R is there. If it is, we'll share this message that says we found R. And then it's an if-else stuff. I didn't show the else part, but the else is where we install R. Another way, that is like looking for a specific place on your C drive to see if R is installed. If R is installed somewhere weird, it won't find it. So the other way we do, and this is it's just sort of case by case depending on what usual default install locations are, is you can do where, and then that will look anywhere on the C drive to find a Git thing. Similar idea, if it's found, it'll respond to a message saying it's found. If it's not found, it'll install it. So this is relatively new to Windows. You can, similar to Linux, apt-get, there's this tool called winget that you can use to install programs from the command line. So it's a Windows package manager, similar to Linux. It comes on all of our computers. If you're running this on your own company, network, personal computer, you won't necessarily be able to assume that because it's a relatively new thing to Windows. But anyways, it automatically installs software. You can add arguments to the command. You can force a location. So that way, that's really helpful for us because then we like know exactly where to look for the software we'll be using later. And then the last argument is the ID argument, which is where you specify which actual software you want to do. And then the top arguments, the accept source agreement stuff, is basically to bypass any sort of pop-up windows that might come up. That's the first choice. That doesn't always work. Our IT department is fairly locked down in terms of what they let us install on our own. So we also have like the second choice, which is where we launch our software center or provide a link and sort of as a secondary thing. And then we just switched to company portal, and there's actually this PowerShell command which you can run to automatically install software from company portal. If that made sense to you, feel free to ask for the code. Part of what we do is we display messages to the user. Fairly low tech, but it's important because it helps people know what they need to do. Some of our steps are still manual. They have to create their own GitHub personal access token. I don't know that we should find a way to do that automatically. But it's nice because it simplifies our messaging and README to focus in on only what they need to see when they need to see it. So if we already found R and our tools and Git installed on the computer, we don't really tell them how to install it. We just sort of can dynamically choose what to display. Here's some more examples of the messages we do. This is a passing case. If they didn't find R, it'd be a lot more messages about like, oh, we're installing R, or oh, you need to go here to install stuff. Just this is more sort of for reference. You can get colors in batch scripts, but you have to use escape characters. They're a little hard to work with because a lot of the text editors will strip it out. So I'll make the slides available if anyone wants to dig into that further, but you can put pretty colors in this. The other thing is we have user input for certain things where they have to make a choice. Earlier versions of the batch script, we'd have a how-to guide that they could view first before they run it. And then we also let users choose where they want to clone our code to and where they want to create their sort of R projects folder. So that here is the top thing is an example of what that looks like in the batch script. Here's an example of what it looks like in the code. You sort of have these like options that are the input variable is something where they set themselves, and then depending on what they put for the input, we send people to different parts of the code and execute different things or not, depending on what they want to do. We also have this folder chooser thing, so you don't have to type in like a folder path. You can click through here, this little pop-up box, and find the folder that you want to use for the R projects. And then if the folder doesn't exist, it's created. If it does exist, we just set it. The stuff at the bottom is sort of examples of that code. Here's the actual code for the folder picker. Not important, but kind of a cool example of using ChatGPT. I found online code would let you choose a folder, and this is written in Visual Basic, which is a language I do not know. So ChatGPT actually in this case worked fairly well. I told it to modify the code so it would let me choose a file, or sorry, this is reverse. The code I found was choosing a file. We wanted to choose a folder. So I asked it to modify the code so it would choose a folder instead of file, and it just spit all this out, and then I ran with it. Another important part of what we put in batch scripts is Git operations. We store all our code on GitHub for version control and whatnot. But like within the batch script, we need a way of making sure that the code that they have locally on their computer, because all this is running locally, is synced up with GitHub. So we write these commands into the batch script to make sure we're in the same branch and make sure all the data is pulled correctly, the right version. And then sort of the final bit to this is you actually run the R script. Prior to that 4.40 vulnerability being discovered, we actually supported multiple versions of R, and then we sort of had preferentially which versions we wanted. So that's what this code was, where we were preferentially running 4.2.1. So it would look to see if it had any of the supported ones, and then it would overwrite the least favorable one with the most favorable one. We've currently changed that to only support 4.4 because of the vulnerability. But anyways, you can do it that way. And then after you have that, it's just you have the location of the R executable. It's important to use the R script, not the r.exe. And then the second argument is the R script you actually want to run. And anyways, that's how we put it in the batch script to run the data refresh without them ever having to open RStudio or run stuff themselves. Okay, not the main point of the talk, but what does the R script do? There's also some other things we built into the R script itself to make the code reproducible. We use rend for package management. We have a few other sort of environmental checks that actually run out of R, like checking to make sure the VPN's connected. And then of course the R code does the whole actual data processing. I glossed over a lot. Feel free to ask about code. There's a lot of other sort of tweaky details you have to do to get it right, but that's the main thing. Why not PowerShell? And this really should be titled Why Not X, Why Batch Scripts. PowerShell would also be, we use batch scripts because you can pretty much assume that any Windows desktop environment will run them automatically out of the box. You can just double click on it. You can't write an R script to install R because you need R to run that. So that's sort of why we use batch scripts. We didn't use PowerShell, which is the other sort of Windows shell language, because it's slow and I don't really know how to use it. So if you have ideas, feel free to connect out afterwards. And then sort of a final thought, there's nothing that limits you to doing just R. You could do pretty much anything that can be run from the terminal. You can do Databricks stuff or Power BI, that's the stuff I want to work with. This would work equally well for Python. In fact, like some of the Conda environmental setup stuff is written with batch scripts anyways. And then you can put it on the task scheduler. So if your IT doesn't give you access to the cloud and you want to do these sort of system admin things on your own, it's very possible. Here's my contact. If you want to see the code, it's at that link. You can email me at my work email. You can find me at LinkedIn. If you work for Washington State Department of Health, feel free to reach out to our team about some of the other stuff we do.